So question 15. We've got a 6-sided dice was thrown repeatedly. After every 100 throws, the cumulative, and that's highlighted, I'll come to that in a second, the cumulative number of 6s thrown was recorded. Complete the table below, which gives a summary of the results obtained. So we've got a table here, we've got 2 missing pieces of data. Now, cumulative just means the running total. Okay, so after 100 throws, a total of 8 6s were obtained. After 200 throws, a total of 28. So the second 100, they were 8 in the first 100, then 20 in the second 100. But put out of 200 throws, you had 28. Okay, that's how you work them out. That's what they mean by cumulative, just a running total of how many 6s were obtained in total. Now they're asking for the relative frequency, and relative frequency is literally just the probability of it happening. So if in the first scenario, let's say 8 6s, you had 8 6s out of 100 throws, the probability is going to be 8 out of 100, or 0.08. Okay, 28 6s out of 200, that'd just be 28 over 200. You can then simplify it to get the decimal 0.14. Okay, and that's what we're going to be. That's what we're asked to do now. We've got to make 60 out of 300, because that's obviously the probability. A decimal, and there's 2 ways to do it. You could do 60 divided by 300, which is probably a little bit more challenging than just working it out as out of 100. Okay, so if you work it out of 100, you've got that many hundredths, and that's just the decimal answer then. Okay, so to go from out of 300 to out of 100, you just divide by 3. Okay, divide the top number by 3 as well, obviously. So that's going to be 60 divided by 3 is 20. So you've got 20 hundredths. So 60 out of 300 is the same as 20 over 100. And that is the same as 0. If you've got 20 hundredths, you've got 0.20. 20 hundredths. Or just 0.2 if you wanted to. Okay, that's the first one done. Second one then is 80 out of 500. To make that out of 100, okay, we just divide by 5. So I'll divide the top by 5, which is 80 divided by 5 is 16. So the answer here is 0.16. Okay. Now, question B, which I've kind of drawn on a bit here. It says, draw a relative frequency diagram to show the information given in the table. Here we go, so here's the table. They want to know, after the number of throws, they want to know the relative frequency. Okay, so it's just this. Now, you could plot some of this as best as you can, even if you didn't have this, couldn't you? Okay, but obviously you're going to need it for the full marks. Oh, it's only 1 mark actually. So, we haven't got a scale here, but I know I need to go up to at least 0.2. So to make this easy on myself, I'd go 0.1, or 0.10 if you wanted to, whatever you wanted to call it, and 0.2, and then 0.3. So I know then I've got 100th, 200th, 300ths, all the way to 10 hundredths, or 0.1, and then 20 hundredths, 0.2, and then 30. So every 1 square is 0.01. Okay, so if I wanted to plot now, after 100 throws, I got 0.08 as a relative frequency. That's what I'm plotting. So I just go up to 0.08, 0.01, 0.02, 0.03, 4, 5, 6, 7, 8. Make a mark, and that's it. Next one, 0.14, 0.1, 0.11, 1, 2, 1, 3, 1, 4. Here we go. Next one, 0.2, after 300 throws. Number 4 is 0.18. Number 500 throws then is 0.16. There you go, should be right. And well, that's it. What you'll see, guys, is from the table which value gives the best estimate for the probability of throwing a 6. Okay, for the table here. Now, you must give a reason for your choice. It's a 1 mark question. If you don't give a reason, you're not going to get a mark. It's as simple as that. Okay, so they're looking for the best the best probability out of these, okay? And the most reliable probability, which would be the best probability, okay, would be the one that's been conducted, would be the probability from the experiment that's been conducted the most, okay? So after 100 throws, your answer is not going to be as reliable as after 500 throws. If you think about it logically, the more throws you do, the better you get at understanding the probability, okay? So the answer would be 0.16. I'll write it here, 0.16, and that's because the experiment's been conducted more here than anything else before. So 0.16 because I'm going to say experiment has been conducted more times. Make a comment if you had more room. My paper's only A5, so it's not as big. You can make a comment saying that the more times the experiment's been conducted, the more reliable the answer is. Okay. Question D now is: do you think this is a fair dice? You must give a reason for your answer. Okay. Basically, 0.16. If you think about it and you think about a dice, the probability getting a 6 on a dice would be 1 out of 6, wouldn't it? Basically, if you think about it. So the question is 0.16 similar to a sixth? Okay, you could work that out quite easily. There's a few ways to do this, if I'm honest, but I'll just do the mathematical route. Is 1/6 anywhere near 0.16? That's the question. All right. If they are similar, you could say yeah, it's a pretty fair dice. If it's way off, you can't say that really. Divided by 6. So I'll just do 1 divided by 6, which is doesn't go into it. Carry the 1. 6 goes into 10. 1's carry the 4. 6 goes into 40. 6 times. And then you carry the 4. Yeah, so a sixth is basically 0.16. Let's say 7. Okay, because I know it carries on to be 0.166 recurring. So 1/6 equals 0.16 recurring. Okay, which is pretty close to a sixth, which is pretty close to 0.16, which is reasonably close to 0.16. So the answer, okay, is it? The question is it a fair dice? So this is a fair dice.